Hello, let me introduce myself. My name is Randy Carlos Manuel. My name 19209-019. I am from the 4 group. On this occasion, I will present material about concise environmental engineering for the material 10 and 11. Okay, alright to the material. Okay, the first material is sound pollution. Noise is defined as an unwanted sound in environmental engineering. This is different from the definition of noise in other fields where noise usually means unwanted information or data that is not relevant to the hypothesis or theory being investigated. For example, in telecommunication, noise is the unwanted random addition of a signal. With respect to noise, noise does not have to be random, e.g. loud music from neighbors. Noise effects range from moderate to permanent hearing loss and can be assessed differently by different observers. At this time, noise is pervasive and it's almost impossible to avoid it. It is important for environmental engineers to understand noise so that its effects can be reduced on the design and operation of various buildings and machinery. In the material sound pollution, there are several important things. One is 10 the point of one noise sources. Noise can come from point sources, e.g. loudspeakers, channel sources, e.g. power lines under strong winds, or regional sources, e.g. wind noise from the forest. They include sources from road traffic, aircraft, industrial plants, construction activities, sports and crowd activities, loud music from neighbors, etc. In time, noise can be classified as: first, continuous. The sound is not interrupted during the observation period. Second, intermittent. Continuous sound with interruptions such as dentist drill. Third, impulsive. Short duration sound, usually less than 1 second, like a shoot. Next, 10 the point of 2 physical properties of noise. Noise is a wave that is described by wavelength, frequency, and speed. Sound is compression wave and causes change in pressure in the air. Sound pressure, also called acoustic pressure, is a deviation of local pressure from atmospheric pressure, which is driven by sound pressure. Sound waves that can be measured using a microphone in the air and a microphone in the weather. Next, 10 the point of 3 human perception of noise. The human ear responds differently to different frequencies. Human voice contains frequencies between 80 to 8000 Hz, but mostly in 500 to 2000 Hz. In practice, noise with frequencies above 8000 Hz is usually ignored in monitoring environmental noise because it is rarely encountered. For noise analysis, the entire range of audible frequencies is divided into a set of frequencies called bands. Each band covers a certain frequency range. Next, 10 the point of 4 noise measurement. Noise is measured by sound level meter. The microphone is one of the main components in the sound level measuring system. During measurement, it must be protected from mechanical damage, moisture and turbulent noise from wind. The windshield and special rain cover attached to the microphone should be used if possible. Sound level meter must be calibrated by a piston pump or sound level calibrator before and after use. When measuring noise levels from a particular point source, distance must always be stated. A distance of 1 meter from the source is usually used. If the distance from the microphone to the sound source is removed when the measurement is quoted, it will make the data useless in the case of measurement of the environment around background noise. Distance does not need to be equated because there is no single source. Next, 10. The point of 5. Health effects. Noise can damage human psychological and psychological health, causing interference and aggression, hypertension, high stress levels, tinnitus, hearing loss, sleep disorders, and other harmful effects. Chronic exposure to noise can cause hearing loss caused by noise. In animals, noise can have an adverse effect on their behavior, increase the risk of death by changing the delicate balance in the detection and avoidance of predator or prey, and interfering with the use of sound in communication, especially in relation to reproduction and navigation. Noise pollution has caused the death of certain species of whales that have been stranded after being hit by a loud military sonar sound. Next, 10. The point of 6. Noise control. There are 3 elements to consider in noise control: source, transmission line, receiver. 1. Source. Noise generation can be stopped or limited to certain times of the day. 2. Transmission line. This can be modified by placing the source in a soundproof enclosure, building a noise barrier, or using sound-absorbing material along the path. 3. Recipient. Wear ear protector or change work schedule. Okay. Next material is climate change, impacts, mitigation, and adaptation. Climate is a long-term statistic. The standard period is 30 years. Meteorological variables, e.g., temperature, humidity, atmospheric pressure, wind, etc. Statistics include averages, variance, slope, and others. The climate of a location is influenced by land use or land cover, latitude, terrain, altitude, etc. Climate change has major implications for assessing environmental risk and sustainability. In the future, it is important for environmental engineers to understand how climate can be changed by human action intentionally or unintentionally, and what mitigation and adaptation approaches need to be adopted. Next, 11. The point of 1. Climate observation. The details of modern climate are known through measurement of weather instruments such as thermometers, barometers, and anemometers over the past few centuries. Satellite can also be used to pick up surface temperature in clouds. Free condition generally through measurement of infrared thermal images. Paleoclimatology is the study of past climates during a large period of Earth history. This tool uses evidence from ice sheets, tree rings, sediments, coral, and rocks to determine past climate. The reconstructed past climate show variation in climate in various periods of Earth history. Next, 11. The point of 2. Mechanism of climate change. On a planetary scale, global climate is governed by how much energy the Earth receives from the Sun. However, the global climate is also influenced by other energy flows that take place in the climate system itself. This global climate system consists of the atmosphere, ocean, ice sheet, living organisms, and soil, sediments, and rocks, all of which affects the movement of heat throughout the Earth's surface. Next, 11. The point of 3. Modeling climate change. Despite the difficulties and uncertainties with climate modeling, many research organizations have developed climate models to help assess various coercive components and feedback. There is still a long way to go before this model can provide accurate estimates. Climate models use quantitative methods to simulate interaction of the atmosphere, ocean land surface, and ice. They are used for various purposes, from studies of climate system dynamics to future climate projection. The use of the most talked about climate model in recent years is projecting change in temperature resulting from increased concentration of greenhouse gases in the atmosphere. All climate models take into account energy that enter from the sun as shortwave electromagnetic radiation, especially infrared and shortwave, and outgoing energy as long waves. Infrared electromagnetic radiation from Earth. Any imbalance results in temperature change, GCM. Discredit equation for fluid movement and energy transfer and integrates them for time to time. Next, 11. The point of 4. Importance of natural variability. No climate model can adequately predict or even explain this rapid transition. Short-term variation in weather and climate are clearly within the natural variability of climate to the extent that we can realistically assess. In addition, these models are not really approximate models. They are just research models designed to simulate responses to anthropogenic change hypotheses, to weather and climate. Other things being a quality simulation model should be more accurately called a process study, not a prediction, with their many limitations in their description of climate pressure and feedback. They are unable to know about all the processes that are important for climate change to include them in quantitative forecasting systems. Next, 11. The point of 5. Impact. The impact of climate change is reflected in change in various aspects of concern to creatures and ecosystems. In the physical world, climate change triggers global and regional weather change. In general, future climate change projections on a regional scale do not have as high a level or scientific confidence as projections made on a global scale. Temperature changes are more visible on land and polar regions than in the ocean, and more in high latitude than in low latitude. Rainfall throughout the world is expected to increase, but with a substantial shift in where and how rainfall falls, intensity, frequency, and type. Next, 11. The point of 6. Mitigation. Climate change mitigation is human intervention to reduce the potential impact of climate change by reducing source or increasing the amount of greenhouse gases. It should be noted that stabilizing GHG emission is not enough to stabilize GHG concentration. Examples of mitigation include using fossil fuels more efficiently for industrial processes or electricity generation, switching to renewable energy, and many more controversial nuclear power, increasing building insulation, and expanding forests and other things to remove large amounts of carbon dioxide from the atmosphere, changing individual lifestyle and business practices. Next, 11. The point of 7. Adaptation. Adaptation to climate change is taking action to overcome the effects of climate change. Adaptation is needed because climate change and its impact cannot be mitigated in a short time. Adaptation will be more difficult for larger magnitudes and higher rates of climate change. Climate change adaptation is very important in developing countries because these countries are predicted to bear the burden of climate change impacts. Adaptive capacity is closely related to social and economic development, and developing countries generally lack the ability to adapt.